In this video, we want to look at the associative properties of addition and multiplication. So associative properties. Inside of the word associative is the word associate, which is very useful to think about as we look through a few examples here. Let's consider 2 plus 4 plus 5. Clearly, if I write 2 plus 4 plus 5 again, it must be true. But let's consider the different ways we could add 2, 4, and 5. With the associative property, we can't change the order like we did in the commutative property. The commutative property could still apply to this problem, but we're not using it here. What we're doing is we're considering how we could add things that are next to each other. So typically, when we have 2 plus 4 plus 5, we would start at the left-hand term and add the next term. So we would add 2 plus 4, then add 5. You could think of that as putting parentheses around the 2 and the 4 and adding them first and then adding the 5 to that sum. What would happen though if we add the 4 and the 5 first? Let's just work through it quickly to see. On the left-hand side, we would get 6 plus 5. On the right-hand side, we have to add the 4 and the 5 first, which is 9. So we have 2 plus 9. And then we would continue adding, and we will get 11 equals 11, which is very true. So adding the terms and by grouping them in a different way, in other words, adding the second two terms first instead of the first two terms first, we will get the same answer. Now, if we try the same thing using subtraction, things just don't work. Let's consider this problem. And let's put some parentheses in here. If we do the subtraction with the first two terms first, as opposed to grouping this way, we will get a very different answer. The difference between 2 and 4, if we take 2 minus 4, we get negative 2 as our difference. And when we try to add 5 to that, we would end up with the left side having a value of 3. If we look at the right side, if we put the parentheses the way that I have, we get 2 minus the sum of 4 and 5. So we're subtracting 9 from 2, which gives us negative 7, which is clearly false. So I probably should have a question mark here and a question mark here, and then in this step I should say it is false. Since it's false, it's clear the associative property does not work with subtraction. Now, can we make it work? And the answer is yes. Just like with the commutative property, I can rewrite this as an addition problem and make it 2 plus the negative of 4 plus 5. And if we do that, you can verify for yourself, we could add in any order that we want, which should make sense if we were looking at a number line. Adding 2 means we go 2 units to the right. Adding negative 4 means we go 4 units to the left, and adding 5 would mean we want to go 5 units to the right. And it shouldn't matter which order we do that in, we should end up at the same place. Now, let's consider what would happen for multiplication. So if I turn this around and make it into a multiplication problem, 2 times 4 times 5. Let's see, if I rewrite 2 times 4 times 5, clearly that will be true. But let's associate these factors now, because we're multiplying, in different ways. If we look at these factors, we take 2 times 4 first and multiply those and get a product of 8, and we will multiply that by 5. On the right-hand side, we would first multiply the 4 times the 5 and come up with 20. And so we will have 2 times 20. 8 times 5 is 40. And 2 times 20 is also 40. It looks like it works. You can verify by putting any numbers you like in, and it will work. This should make sense because this is like having a 2 by 4 by 5 box. Dimensions are probably not great, but gives the example. Having a 2 by 4 by 5 box will give me exactly the same volume as having a 4 by 5 by 2 box. So associating the sides in different ways will still give us the same volume when we multiply them out. Now let's consider division. If I have 2 times 5 all divided by 4, does it matter how I associate the 4 in this case? So let's consider the two following examples. Let's consider whether, let me rewrite it this way, and let me write the 4 under the 2, and then let me rewrite it again, and this time write the 4 underneath of the 5. And let's do a little association here. And let's compare these three quantities. So in the leftmost case, we would multiply 2 times 5 first and get 10, and then divide by 4. In the second case, we would divide 2 by 4 and get 1/2, and need to multiply that still times 5. In the third case, we would have to take 2 times 5 divided by 4. We're going to cheat a little bit and switch to decimals. We'll call that 1.25. So now, if we do division of 10 by 4, we should see that we get 2.5. If we take half of 5, we should get 2.5. And if we double 1.25, we will get 2.5. So associating the 4 with the 2 or the 5 first didn't seem to alter the answer to the problem. In any of these cases, we're doing all of the same operations, just in different order. In fact, we'll see later that we could turn this strictly into a multiplication problem and say that we have 2 times 5 times 1/4. And since we can use a commutative property with multiplication, we could first multiply the 2 by 1/4 or the 5 by 1/4, and it would be the same as dividing by 4. So changing the order around and associating in different ways works for division, just like it does for multiplication, which will be very handy as we're working with fractions.